Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, I am Mr. Salami EA. Welcome back to physics class again. We are going to start from where we stopped in our last lesson, which is continuation of Hooke's law. We have discussed about Hooke's law before now. Then according to Hooke's law, we have F, which is force, equal to what? Ke. Then in our last class we said F here is force, K is the what? Elastic constant or stiffness of the material, and E here is extension. Now if I want us to make this K, which is the elastic constant, as the subject of the formula, then what's the coefficient of K here is E. Then you now divide both sides by E. Divide both sides by E. And when you divide both sides by this E, you will discover that you will have K equal to F all over E. We have it as well, F all over E. Since F is measured in Newton and extension is in meter, elastic constant will be measured in Newton per meter. That is, if you look at it now, F we are having here is in Newton and E here is in what? Meter. Then you will have it as well, Newton all over meter, which is the same as Newton divided by meter. And this division there, we said it in our last class that division means pi. That is why we said that what? Newton per meter. Newton divided by meter is still the same thing as what? Newton per meter. Therefore, the SI unit of what? Elastic constant is Newton per meter. Then elastic limit is the limit of force beyond which the stretched wire does not return to its original length when the stretching force is removed. Now let us look at the examples. We have discussing about the theoretical aspect of elasticity before now. Now let us see how can we solve some problems on this particular topic. Now example 1. A force of 0.8 Newton. We said in the other class that what we have N here, anytime you see capital letter N attached to a number, you should know that what? That number is what? Force. That number is what? Force. Because it's the unit of what? Physical quantity we have as a force. A force of 0.8 Newton stretches an elastic spring by 2 centimeters. Stop. Find the elastic constant of the spring. Find the elastic constant of the spring. What you have to find is the same type of stiffness of the material used. The stiffness of that spring used is what you have to look for now. Then before you get to that, you must bring out the data we have. Bring the data we have in these questions. It's from the data you have to tell you which expression, which equation you are to use. Then what are the data we have here? We have force. We have force. Then what's our force? 0.8 Newton from the question. 0.8 Newton. Then we have the extension 2 centimeters. And you don't work in centimeter. If you go back to our previous lessons, we said that what? The elastic constant is measured in Newton per meter, not in Newton per centimeter. Newton per meter. That is why we decided to convert this centimeter to meter. And when you are converting centimeter to meter, you just have to divide whatever given to you by 100. That is why we have 2 divided by 100. And when you divide 2 by 100, what you are going to have here is 0.02 meter. You write M there, which is meter, not in centimeter, because we have converted from centimeter to meter. Then after that, what we have here is what? F. We have E. What we have to look for is what? Elastic constant. And according to Hooke's law, we have F equal to what? Ke. From the Hooke's law, we have this expression. And from this expression, what we have here, we have 3 parameters here. We have F, that stands for force. We have K, that stands for what? Elastic constant, what we are asked to look for. And we have E as what? As our extension. And if you look at this now, we have gotten F, We have gotten E and we don't know K. That is what we have to look for. Then what can we do now to get our K? You make K as the subject of the formula. Then what can we do to make K as subject of the formula? E at the front of K here is the coefficient of K. Then you will now divide that E by both sides. When you divide E by both sides, we have our K equal to F all over E. That is K divided by what? F all over E. Then after getting this, substitute all the parameters given to you here now back to the equation. Wherever you see F, what is our F? 0.8 Newton. Wherever you see E, what is our E? 0.02 meter. Substitute it back to the equation, you will now have K equal to 0.8 Newton divided by 0.02 meter. Now, when you divide 0.8 by 0.02 meter, you will now have your K equal to 40. K equal to 40. What we are having here is not just 40, it's what? 40 Newton per meter. Why do we have the unit here? The unit here now tells us that what we look for now is not force. What we look for now is not extension. What we look for now is the elastic material. The unit of any physical quantity tells us the kind of physical quantity we are looking for in such problems given to us. That is why we have 40 Newton per meter. That is the elastic constant. Now if you look at it now, when you divide 0.8 by 0.02, forget about the unit. Look at the numbers given to us here now. By using calculator, divide 0.8 by 0.02. What calculator is going to give to you is what? 40. Then you will have your answer as K to be 40. You will not leave it as 40 because we don't know whether that 40 here is 40 amps or 40 bins. What you will now go back to the unit used. What you have as the numerator here is N, and what you have here as the unit of the denominator here is what? M. Divide that M by what? N. N by M. That is N divided by M. Newton divided by meter. I told you that what divide is what? Per. Means per. As you have 20%, it means 20 divided by 100 because cent is 100. Percent, 20 divided by 100, cent is 100. The same thing with what you have in an N divided by what? M is what? Newton, where N is meter, Newton, and M is meter, you have it as what? Newton per meter. Then your final answer for this, K now becomes what? 14 Newton per meter. That is that for that. Now we are going to the second examples. The second example, we have a force of 2 Newton stretches an elastic material by 30 millimeter. If you look at what we have here now, the extension we have here is in millimeter. In our first example is in centimeter. Then you also, at the end of the day, you are still going to convert. Now let's continue. What additional force will stretch the material 35 millimeter? That is another extension. Assume that the elastic limit is not exceeded. Now let's go to the solution to this question. Now we also bring out the data we have in that question. The first data we have there is force, which is F equal to 2 Newton. Then we have extension. This extension here is the first extension given to us in the question, which is what? 30 millimeter. And this 30 millimeter, you need to convert it to meter again. Then when converting from millimeter to meter, you divide by 1000. But if you are converting from centimeter to meter, you divide by 100. You look at the difference now. From millimeter to meter, divide by 1000. From centimeter to meter, you divide by 100. That is why we have 30 divided by 1000. And if you calculator to divide 30 by 1000, what you are going to have from the calculator is 0.03 meter. Then after this now, you will now look for what? Elastic constant for the first extension. You look for the elastic constant for the first extension. Then to get elastic constant, make K here now. We have K equal to F all over E. What is our F? Is 2 Newton. That is why we have these two here. What is our E? Is 0.03 meter. That is why we have 0.03 here. Then if you also use the same calculator to divide 2 by 0.03, you are going to have your K to be equal to what? 66.7 Newton per meter. The Newton here is the unit of force, which we have as the denominator. The meter here is the unit of what? E, which we have as what? Extension here. Therefore, the unit of what? Elastic constant, here now we have it as what? 66.7 Newton per meter. After getting this now, you are going to use this to get the extension for the second, to get the force for the second extension given to us in the question. Then after getting that, from there you will now get the additional force. You will now get the what? Additional force. Now look at the second extension given to us from the question is 35. Then you also convert this 35 millimeter to meter by dividing it by 1000. We have E equal to 35 divided by 1000, and when you divide 35 by 1000, what you are going to have here is what? 0.035 meter. 0.035 meter. 0.035 meter. After that, now look for force. You look for force, which is F. From there, we have used F equal to KE from Hooke's law. F equal to KE. Substitute all these parameters now back to the equation. From the initial extension given to us, we use it to get our K. What we have as our K is 66.7. Then from the second extension now we have 0.035. 0.035. Then from Hooke's law, we have F equal to KE. Then after getting that, substitute all the parameters back to this equation. From the first extension given to us, we are using to get an elastic constant, which is 66.7. Then the extension we have here now is 0.035 meter. Substitute it back to E, you have F equal to 66.7 multiplied by 0.035. Then if you use calculator to multiply this, what you are going to have as your force now becomes F equal to 2.33 Newton as our force. Then after getting this now, what you have to look for is the additional force when the extension is 35. The force we have when the extension is 30 is 2 Newton. What will now be the additional force if the extension now increase from the initial extension to this final, which is what? 35 millimeter. To get that, the force given to you, which is 2, then you now subtract it from the final force we have here now. Then you now have the additional force to be equal to 2.33 Newton minus the initial force, which is what? 2 Newton. Then from there you have your additional force to be equal to what? 0.33 Newton. That is the final for that is the solution for the example 2. Now, after that, what I want you to do is to take this as take-home assignments. Then when you get back to your house, the first thing I want you to do after taking your food, then you bring out your exercise notebook. Try this by yourself and ensure that you get an accurate answer. I believe if you follow what you have done so far, this assignment will be very easy for you to solve. Thanks for today.